Hi, and welcome again to Environmental Geology. This will be the beginning of a series of the last lectures on the last one quarter of the course now. This will be lecture 11, and the focus today will be on waste disposal. Waste disposal, you can follow along in the text. It's chapter 15 in Montgomery's Environmental Geology book within that Primus text that you have. So what I hope to focus on today will be a number of things that we put into landfills. Kind of the main focus will be on some of the problems that are involved with landfills, maybe the kinds of landfills that there are. We'll look at our local landfill here in Hayes and some other far-reaching ones I've seen in my travels and talk about some of the issues, environmental conditions with these landfills. So I guess a nicer way of talking about it is a waste disposal. We're going to take different kinds of waste from just regular stuff all the way to some rather dangerous things and talk about the disposal conditions with it. There probably won't be a lot of notes per se of text that you'll see on the screen today, a lot of imagery, but be sure to pick up on some of the major points, might have starred or underlined, that come up on the screen to follow along with that, okay? Now, I know this is not our typical waste disposal type of situation, but we talked a little bit about water situations in the last lecture, and of course we talked about stuff that goes down. If we use our water supply, if we flush water out or rinse water down, it goes into the sewer system. And so in a way, a lot of money and material can go down the drain, so to speak, but if we take a look at that kind of a waste product, kind of a sewage type waste product. If you live in the countryside, it's not really involved per se with a sewer system. That's kind of a nice connective thing that has to go to a landfill eventually, or can go to a landfill, parts of it do. But if you live in the country, you have a septic tank. Now this is not about the detail of the functioning of a septic tank system, but basically the sewage will leave the house, go into a settling tank. The solids will settle out, the liquids go off into a leach field, and these pipes out here are perforated, and usually a big sandy, gravelly body around that. And nature kind of takes care of that liquid portion, so to speak. So depending upon where you live, you might have a situation like this, but normally in major communities where we create a lot of waste, one of those small waste products has to do with the sewage treatment plant. Now we take a lot of this material. You take that garbage, the effluent that goes down your sewer line, it gets processed at the plant. The goal of a sewage treatment plant is to take that waste. This is the Hayes sewage treatment plant from the air, and this where the cursor is right here is one of the main buildings. And so you initially separate and break down that sewage into solid components and liquid. And the goal is to put the liquid through a number of steps to make it cleaner and cleaner and cleaner, add some chemicals to clean it, then eventually dump it. And so I'm not going to spend a lot of time on that because that's more of a water issue in terms of sewage. Eventually it goes through here and is dumped into a little spot called Chatola Creek, and that water is prepared as kind of reclaimed water that goes downstream then. It's cleaned by nature. It's kind of spread on the surface of the land, goes downstream, and then nature cleans it up before it gets to the next community. But there are solids that come out of this product. In the sewage treatment plant, again, there's lots of different steps we could go into, from an aeration process up here in the top right-hand corner to a trickling type of system where we trickle water over these rocks, and bacteria help break it down even more. The microorganisms help clean the water. But we can still have solid material left over, solid waste. And in the case of this solid waste here, you see in the top left part, that's still in a strange kind of non-breakable scenario. This is taken to the transfer station in Ellis County. We don't have a county landfill anymore that we can put this waste in. It's taken out there, but then it's sent to another part of the state. And many municipalities have the same thing, that their landfills are filled. And so there are special places now, bigger holes in the ground, that we're taking this waste to and disposing of it. Down in the bottom right-hand corner, it's kind of a more organic-rich type of sludge that's left over. And this, of course, can be given to local ranchers or farmers to spread on the ground. It's kind of nutrient-rich and is part of that product. So we can, the key thing here is stuff that's recycled and is waste that goes to landfills is in the top left part of that picture. But there's a lot more garbage I want to talk about, and we're going to look at a couple of pie charts now that deal with certain areas of our society where we have, certain kinds of solid waste and categorize them. And the ones that I want you to remember as far as this chapter, this lecture is concerned about, are the big ones. What are the main or top sources of solid waste? And if we look at this, animal waste is 39%, which is really large. And of course, mineral extraction and processing, the stuff that's left over, the slag or the tailings that we put up in piles, has to be put somewhere. So minerals, more geologically oriented, and biologically, the animal waste that we've got. If you look at the bottom part of the pie chart, from crops to municipalities and industry. Industry is the smallest one on there. And so write down for now, as far as the main, the two biggest principal sources will be mineral extraction and processing and animal waste. There'll probably be a question related to that on the exam. Another pie chart in your text deals with more of the industrial solid waste. Some of the industrial solid waste is more of a concern because of some of the chemical and toxic nature of some of these types of products. And again, I'm not going to go through every possible scenario in here. You can look at these and kind of be aware of them. But again, I want you to remember the top two big ones. Chemical and allied products, things related to the chemical industry, are just under 20% of the waste. And then paper and its related products are just around 14%. So the two big ones within the industrial area, even though the industry is small, and if you look at a lot of these, there's a lot of chemicals associated with this particular area. And some of these are toxic, and we have to be concerned on how do we dispose of that? And how do we kind of protect our groundwaters and surface waters from these solid waste once we have to get rid of them? So paper products and chemical products. Let's take cities or municipalities. Typical composition of city solid waste. It says soil waste. It should be solid waste. I believe that's a typo in the text. Yeah, it is. But look at the number one. Has been for quite a while. Paper waste. Lots and lots of paper waste. Well, I know when computers came on strong, we thought we would save a lot more in paper. Well, that will vary, and we still haven't really reduced that enough. But all of these have created other industries in terms of recycling as well. Industry recycles stuff, city can recycle stuff. So a lot of solid waste are recycled, but remember that the number one biggie is paper waste. And we're working hard to reduce that particular one on this chart. So we've got all these wastes. I remember when I was a child up in northern Wisconsin, one of the fun things to do was go to the dump. That's what we called it. It's on the north side of town. We went out to the dumps. We'd take all our trash out there and our garbage, and if we had more time, Dad would let us get the .22 rifle out and shoot rats. And that was kind of a fun thing to do. You always knew when activity was going on at the dump because you could see it. You look up in the sky and you see the great big cloud where they'd burn it. There was always a certain day they'd burn a certain amount of that garbage. Well, at that time, that was causing a problem. They called it air pollution. It would smell, and the air pollution didn't look good, and our society was growing. We had more piles to get rid of, and so we said we better do something. So we passed the Clean Air Act and said we're going to bury this stuff now so we can't see it. And we called this a landfill. Okay? Now once we started doing that, we realized that not only were we at times in certain areas running out of space for holes in the ground, these landfills, to put our waste and trash into, that also something else was happening. That water was leaching into, or going into these landfills and chemically breaking down material, leaching things out, and sometimes even making the toxicity of some of this stuff even more intense. And it was leaking out of these landfills in different ways, sometimes on the surface of the ground or else soaking inward. So we said, now we're going to create what we call sanitary landfills. So our vocabulary changed. At Doesn't really matter what you call it because there's really no true perfect landfill. We're pretty close to that. But it takes a lot of money to create a really good sanitary landfill. So we're going to look at some of these issues now related to this. I know that as I travel across the country, there's a variety of places you can go to. I mean, traveling through the Appalachian Mountains, you come across this spot, and there's all this trash on the side of the road. Somebody instantly created their own sanitary landfill. They said, I'm going to dump it here. Because usually you have to pay to take your trash to a landfill. Well, if you don't want to pay, you just dump it. Kind of a midnight skulkers group and dump it anywhere. And a lot of that happened. And a lot of that was a cause for groundwater pollution and surface pollution. And it, you just don't do that. And as we progressed through this, we realized there were different kinds of trash that had to be disposed of. Some trash is really nasty and some trash is kind of okay, so it can naturally break down. So you see a lot of signs like this around the country. You can see also some of people's opinions of things like this, unless they were just out target shooting, for the heck of it. But there are bullet holes and other things in this scene. Here's a shot of a kind of a landfill to kind of show you what I mean. You dig a hole in the ground, a trench. Fancy name for it is a cell. And eventually we created certain allowable depths and widths to certain regions, and there were regulations and rules on how you fill the hole with the trash. And what are you supposed to do when you finish completing the hole and cover it up? You look at this thing, the Lowry landfill, the picture out of your textbook. There's a lot of trash on the surface. Wind can blow that stuff around. There's a lot of rainwater or drain water that's filled this in. A lot of good chemical reactions going on to leach bad chemicals out of here, which of course are going to do what? You've ponded the water. You're creating a recharge zone right there. So below that, the percolation rates have gone up, and that stuff percolates down towards the water table, and of course winds up in our groundwater system. Something to think about. So one of the things that we're, in terms of what we try to do to create a good landfill is that you want to have machinery that will kind of go back and forth, very heavy machinery to crush and press and squeeze that trash and garbage together. Now the reason you do that is what? You want to reduce the porosity and subsequent permeability so you have more trash and you have open air. So that the amount of water that could seep in there isn't a lot to kind of slow down that chemical reaction process. Another thing you can see they're doing is that they're starting to bulldoze a soil zone. You want to try to be able to get real good, rich, clay-rich soil. Remember, clays, once they absorb water, suck up and reduce the permeability and porosity. So they're required to put so many inches of overburden. Like example, the industrial landfill here in Hayes, north of town, they're required to put 2 to 4 inches of overburden on there by KDOT. And then they can put some more trash in, they got to put some more soil in. They got to do this on a very regular basis. And so eventually you've got the bottom of your hole, then you got garbage, a layer of soil, garbage, a layer of soil, and you're creating this kind of enclosure that eventually, once that you bury all that trash, then you're supposed to have a final cover. Again, the industrial landfill here in Hayes is required to have 18 inches of cover on the top, 1.5 feet. Yeah, so you can kind of reclaim the land. You're required to kind of re-terrace and resurface that land so you don't have it too steep to have erosion cut down and gully into your garbage and then tear it out and leach it out. Expose it to the wind, whatever. So there's a special kind of slope. It's 3-to-1 ratio right here. 3 horizontal, 1. And so eventually you kind of re-terrace that land and it's supposed to look really good. So that's the goal, to create this really nice enclosure, but we realized there were problems with that. For example, in the beginning when we had this trench where we would put the trash into it, and these are really overly cartoon type of diagrams, they're not as layered and unique as they should be, but notice that the water table is very high. It rained a lot, heavy precipitation, water table rises. Where's the water table? It's in contact with the trash. So the chemical reactions are going to take place and you're going to have stuff leach out of there and go into the groundwater. So depending upon the groundwater flow direction, that has to be checked and monitored by people all the time, usually down slope, down gradient. If you've got a well over one side and that pollution plume moves towards you, you're the one who's going to have a contaminated water well. We had that situation happen in Hayes with the Ellis County landfill, which is now closed. Downhill from that towards Hayes, these two ranches and farms, their water wells were contaminated. And there was a settlement that they came to, and of course now we've monitored that. Certain companies are monitoring that plume. It's reduced, it's gone back, so it's not there anymore. But these are problems all across the country, no matter what. I want to have you learn a new word or add a word to your vocabulary. It's called leachate. Write that word down. Leachate is by definition, for here in terms of environmental geology, will be the toxic materials leached out of a landfill. The toxic materials that are leached out of a landfill. I know in the early phases of landfills, we just dumped any kind of garbage of any style in the same hole. We didn't separate it. We didn't put glass here, metal there, refrigerators over here, TVs with this, refrigerants, paints, tars, wood, branches, grass. It all went together. Today, we're separating that. A lot of things you're so accustomed to right now at home, you begin to separate your trash in the house. You may move out of Hayes and move to another part of the country where how they require you to do that and make you pay for that in your home, okay, part of your monthly bill will be even more stringent. They'll want colored glass here, clear glass there, white paper, brown paper, plastic, everything will be different. Styrofoam here, this kind of metal there. Right now when we take stuff to the transfer station that gets sent to the eastern Kansas, you have to go and separate it and put it in different spots. And the different groups come and pick it up and move it on. Here's another way we could get that same kind of leachate into our surface waters. Here they have this kind of small trench, and they pile up the trash, and then the leaching will occur here, and it'll just run down the slope into the stream. So whether it's surface water or groundwater, it's the same thing. We can contaminate it. And so in the last 20, 30 years, we've been more concerned about how to deal with these landfills. What kind of substances are there? Here's a map I took off the web from the EPA's website, and it has to do with the state of Kansas. It talks about the different kinds of substances. It's hard to read these, and I might be able to pick up on some of this here. The purple here is pathogens, green are nutrients, something multiple, kind of pixelated out here. But the point is, some of it will be in, what in streams are impaired, what lakes are impaired. So we've classified this. The EPA has people out there looking at our streams and testing the quality of them, testing the quality of the water in the lakes. So it's being monitored through time. If it gets to a certain really bad point, then we do something about it. Try to clean it up. But no matter where you look, you're going to have all kinds of things running into that. Here we have sedimentation. That would be clay, and you can get sedimentation problems by runoff from rain. Too much, you'll get muds, and it muddies up the water, reduces the BOD, the biological oxygen demand in the water, and so on. M for mercury. Here are pesticides. There's herbicides. That list can go on and on about what's in there. So we're keeping an eye on it. All right, so here's kind of this idea that it infiltrates through there. So even though the water table's low, first picture I showed you, the water table's up high. That might be a Florida condition. This might be like a Kansas condition where that water table's a little lower. So what could you do to prevent some of these things? What are some of the situations? Here's one that they refer to as the bathtub effect. They said, let's take this landfill and we'll put an impermeable liner on the bottom of it so that things cannot percolate through. It's usually a certain mil thickness of heavy-duty plastic, type of paper of some sort, okay? And then that prevents the water from percolating through. So the water kind of piles up in the bottom of that thing. Well, if it piles up too long, here's what happens. It starts to fill up like, the dripping of your faucet in the bathtub's stopper is shut in there. And so nothing goes down through the ground in the groundwater, but it slowly gets higher and higher and eventually leaks out the sides or margins and then goes down the surface. Now it could percolate into the groundwater on the margins or go right into the streams. So it's kind of like an experiment we went through. Every time we had one situation, something else would crop up. So we keep going after these things to prevent, stuff getting into the surface waters or groundwaters, and there can be lots of things that we have buried that can be extremely dangerous. extremely dangerous, very toxic stuff from, DDT drums and paint thinners and herbicides and pesticides. And sometimes things got dumped, by the way, again, not in this legal fashion through a community, but illegally. 2, 3, 4 in the morning, somebody go out and backhoe a trench, dump their stuff in and get rid of it. Sometimes on other people's property. So if you got a lot of money, here's one thing we can solve that with. We put a really good impermeable barrier on the bottom. We create a variety of different drain systems because some fluids will be denser than others. So you can kind of stack these things and have, drawing off material that's very heavy in its weight and concentrate and cycle that. Or if it's less dense, you can pick that up. If there are gases, biogenic gases that are produced coming out of this waste, kind of cooking underground in here, you could vent that off into the atmosphere. Methane is one of the common ones that occur. Or you can utilize that gas to, run a furnace, heat something if you got a landfill up north or something. So liners, really good liners, and lots of specialized drainage systems to remove the different kinds of fluids, as well as piping systems to get rid of the gases that are produced. Then the bathtub effect is gone. But this is very, very expensive. Really expensive. And there are some really good examples of some high-quality landfills around the country. I thought I'd quickly show you where the Ellis County landfill is. On the left is the northern part of Hayes. This is I-70 and 183 north. If you go just about a mile north of Walmart and hang a left, just in the southeast corner of this section up here is the Ellis County landfill. If you log on to the Data Access and Support Center, DASC, on the web, and they've got a unique little thing you can interactively work with anywhere in the state of Kansas. You can click on, find your hometown, zero in on it, and zoom in, and you'll find your houses. They've got a digital ortho photograph. You can overlay topographic streams, the public land survey system, highways, roads, railroads, rivers, lakes, you name it. It's really cool. Check it out sometime. The DASC website. You go to KU's website, go to the Kansas Geological Survey, and click on the link to the Data Access Support Center, DASC. It's one of the best in the nation. And they've got a little link there called CanView. And when you go in there, you can click on activating images, and it's fun to play around with. Anyway, the Ellis County landfill is about right in here. And of course, by putting all this other stuff on there, we can see where the drainage systems are. And it was these ranchers just south of that who had some problems because the water wanted to move southward. So the surface water and the groundwater percolates down towards Big Creek to the south. And that's how stuff leached out of those landfills. That, by the way, is closed up. It's no longer used anymore. Closed in 1993. Oh yeah, here's the website. You might want to write that down. Instead of the www, http:// is always a given. But after that, it's GIS, Geographic Information System, GIS-dask.kgs.ucans, University of Kansas, .edu/dask. Now we could click on that now and probably link to it. I'm not going to spend a lot of time doing that and kind of go over on our allotted time today. But this landfill was closed in 1993. And since that time, you still take trash out there, but trucks come in and take it to eastern Kansas, around the Topeka area. There are companies who have been created, and City Hayes pays for it. I pay for it in my monthly water and sewage bill that comes in. Just slightly north and to the left of that, and to the west a little bit, is another site. By the way, this is what their website looks like, the main page, and you would want to go to CanView right here. I'm not sure if I have any more about that in there, but that's where you'd want to link into. But if you want other GIS databases, by the way, there's tons of it in here, more than you'd ever want to know. When I take my trash out, when I used to, or I still do, I guess, certain kinds, they'll weigh my vehicle, okay, before I get in there, and when I come back out, they'll say, well, you brought in so many pounds of stuff, we're going to charge you a basic fee, blah, 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 and I wind up paying $8 every time I go. Now, if I know I'm going to be taking trash out there a lot, say I work in construction and I'm going to do it every week because of what I do in my job, then I can buy an annual permit. but I still will pay for that. And you kind of sign in and sign out, and that's how they help operate that system. It helps pay for it. Like I said, just down here is the county landfill in the bottom right. Slightly up here to the north is our city's industrial landfill, not the county, but the city of Hayes has an industrial one. So we put concrete slabs and other stuff out there. Some of the things that we put out there, I think I'll show you a picture of in a bit if I have time, but Fort Hays State students this year have been involved in that landfill. This is a certain size area. If you're into shooting, I guess there's a gun club out here. Okay, if you ever heard about the Hayes Gun Club, or so they have a lot of shooting ranges. But right here in this northeast corner, there's a large open area that they needed to have the volume calculation figured up to say, well, if I got this size of a hole, and I put this much garbage in, and I got to cover it up with this stuff, how long will it last? Do I have a 10-year thing, a 50-year thing, whatever? So we got a small grant from the Kansas Geological Survey to analyze this problem. We're going to be submitting a report here at the end of the semester, but here two of the Fort Hays State students, Curtis and Mike, gone out. They're using a GPS unit, and they GPSed elevations throughout this whole area. We were out there really early this year. You can see the still snow cover. And then they took it into a computer lab in Tamanic Hall and used GIS and did special, it's called 3D Spatial Analyst, and created a computer model of what it would look like when they're done filling in the hole. The blue lines represent where we're going to put, create profiles to figure out the volume and do all that kind of stuff. So it was kind of a fun project working with this landfill. It brought the students kind of close as they... That's okay, don't worry about that. That was one of those wave files I put in there. I apologize if that's too loud, but that's one way to wake you up. There's a bunch of bees, okay? But I don't know if you ever traveled around in your life and you've seen some landfills. This is kind of a little bit of a ha-ha, but not really. This is probably one of our country's best landfills. There are many out there. Next time you go down to Miami, Florida, to Dade County, and go south of Miami, maybe on your way to Key West, okay, you'll see what they've nicknamed, and there are many of these nicknamed the same way in the country, Mount Trashmore. Some of the highest elevations in southern Florida are trash. Now remember, in Florida, the water table is very near the surface. The land is not too far above sea level. So you can't dig these huge holes in the ground, unless you got really special techniques to somehow prevent that from getting toxic leachate into the ground. Yeah, so they simply put the liner right on the ground. Build up an area around that, extend the liner, build up, extend the liner, build up, and see they create these giant mounds of trash. It's a very, very well-studied, that you can go on and visit, check them out. They'll give you a tour. Down there in Florida, it's a fabulous landfill. Really keep an eye on things, on how different types of waste are separated, how they line things, bring in extra sand, bring in clay-rich soils. They got the liners. All the methane that's taken off is recycled and used. It's one really good technological success story in terms of things of that. Now, and of course, 50 years from now, as the garbage grows and our population goes up, this is going to be something we'll be faced with waste disposal like that. But it's one of the highest points in southern Florida. It's the highest, actually, from Orlando on down. But you occasionally will see these landfills all across the country in your travel, and when they're up high like that, they're usually they have liners on the surface of the ground. If you go all the way down to Florida Keys, get on down to Key West, they've got an old kind of landfill. It's no longer used. Mount Trashmore 2, as they call it. It's the second highest spot in southern Florida. Down in Key West, and of course now it's been terraced and they've planted vegetation on the top to prevent erosion. And they've got a little, because it's a unique high spot to go look around on. Every year they'll take and someone volunteers to go out there and put up some kind of patriotic thing. And these are the last couple, I think, that have been put out here and kind of covered. But underneath there is all kinds of trash. and theoretically it's safely protected. Okay? So we've come from the dump to the sanitary landfill. We realized we could pollute the groundwater. We realized we have in some places. We take what money we can get to create a good landfill. Some are really, really good, and some are bad. And that just depends on the funding you have to take care of this. So we have a situation that we need to monitor. So the norm today, the average today, is to drill holes in the ground and put in wells, monitoring wells, all around our landfills to see if, and constantly check to see, hey, a pollution plume popped up over here. We got to do something now. And there's other kind of remedial things you can do to work with them, but we watch it. And very detailed records are kept and descriptions of what they've drilled through, what the composition of the layers are, what the technology of what that well is like, and how the tests are run and done. Watching water tables change, chemical analyses pulled off. Very strict guidelines created by the environmental area to keep an eye on this for us. A lot of jobs in that. Here's some geophysics stuff. We say, this one well showed there's a plume developing, so we'll get out there with electrical resistivity. Usually electrical resistivity is one of the good ones to help target, and then run these survey lines across here and then analyze where the concentration of the plume is and where it's sliding to. There may be old troughs where some of that heavyweight stuff's moving down to a lake or a river, and you want to get in there and fix it up. So lots of monitoring, whether it's direct wells or whether it's kind of indirect through geophysics. This is a apparent conductivity, kind of an electrical kind of characteristic. We're checking them out. Okay? Now another thing that we can do with some of our waste, particularly liquid waste, we can inject liquid waste back underground. And there are numerous examples of different kinds of liquid waste that we do that with. Out here in Kansas, one of the common ones is brine water. Brine water from the petroleum product that we don't want. We want the oil, crude oil, and we put the brine water. We're required to put it back underground in specific rock units at certain depths required by law. And it would be the Kansas Corporation Commission here who keeps an eye on that. And so it's referred to as fluid injection. Now, pushing fluids back underground, remember we took fluids out, you cause the ground to drop. If you put fluids back in, you're forcing water in the pore spaces, okay, and that causes the pore pressure to go up. And when pore pressure goes up in soil or rock systems underground, it weakens the rock and causes it to fail. Now, some of us are going on a field trip here this spring. We'll be in this area. I don't know if we'll feel an earthquake that day or that night, but they've been having little minor small earthquakes and swarms out near a place called Trinidad, Colorado. And you can get on their website and check out a lot of things that they're investigating. They're setting up all kinds of seismograph stations in this region out here. Here's the city of Trinidad, topographic map, and they're burying sensors, like here, this inset in the lower left, put little seismographs in there, and keeping a record, a constant vigilant observation, monitoring the earthquakes, and trying to figure out, where are they coming from, and checking it out. Well, it turns out that these yellow stars, by the way, are disposal wells. We dispose of liquid waste. And so in doing that, we've got a good hold on, the monitoring of it. If you can say, well, there's too much earthquake activity going on here right now. Let's reduce the pressure or the amount of fluid we inject in the spot for a while. Let's kind of take it easy. We'll maybe increase it there, decrease it, so you can still inject, but you don't over-inject to cause major problems, activating old faults or whatever. So these are just some examples. Again, there are numerous examples of this stuff all over the country. These blue lines represent some earthquakes that have been reported. They're not large. Do they have any? I don't believe they have any Richter scale numbers on these, but apparently they're very small scale. We'll be going right through this in about a week and a half here. We're going on a field trip cutting over through this area of Trinidad. So I've always wanted to see fresh lava and wanted to experience an earthquake, so I hope it's about a 4 maximum when I'm sleeping in the tent. All right, what's that? Well, this is some waste area now that is really a big concern that we have in our country and the world for that matter. It's not just our typical everyday average trash that we deal with and what we're trying to recycle. This is nuclear waste. This is a nuclear power plant. So I want to look a little bit now at some of the conditions related to and issues related to our nuclear waste program. Obviously, when we take advantage of nuclear power, we're looking at radioactive material, different kinds of isotopes of uranium, potassium, and thorium, and so on. And again, I'm not going to go through the physics or the chemical thing of the atoms splitting and heat being produced, but the concern is the isotopes, the products of stuff we make. When we make some materials we work with get contaminated, and we have to dispose of this material. And some of these things are extremely radioactive, very dangerous, very carcinogenic, can lead to death very quickly, or long-term ways of dying. And so they have what we call a half-life. A half-life is 1/2 the time it takes for a radioactive substance to break down to a stable byproduct. And different kinds of isotopes have different half-lives. So some of these things are going to be in our ground for a long, long time. I'm not going to make you memorize numbers on how long half-lives are, but these things are going to be there for a very long time, folks. And so we've got to figure out how we're going to put this in the ground. A lot of money is being spent to research areas, to research the technology of how we're going to put this extremely toxic material back underground and guarantee the public that it won't leak. All right? And we're going to look at some of these pictures a little bit about it. This is just a typical cartoon kind of area where, again, we've got these really strong concrete base. Then you've got a liner. Then you've got pipes that will drain things out if there's a leak. Then you've got these encasements of how this is kept in there. We'll fuse things in glass. We'll fuse things in strong epoxy type metals or plastics or whatever, so that water cannot get in contact with it and it cannot leak out into the environment. A really highly sensitive type of site. Some places around the country, though, we'll come across some old scenarios, things where we have stuff that's part of our everyday mining life and geology, and maybe some evidences of our past mining activity. This is an air view on the right of the city of Moab in Utah, and this is the Colorado River flowing through here. Here you can see a great big sandstone ridge. The dark area is the shadow. And as you take this dirt road along the Colorado River before you go around and go into Moab, you could go down the river, by the way, and go way around the bend about 6 to 10 miles and end up kind of at a dead end, and you can hike up and see this beautiful turquoise-looking pond. And what it is, it's a settling pond for potash. They're mining out potash at depth. They bring it to the surface, they liquefy it, put it in these basins, and they evaporate. Then they scrape off the potash, of course, and use it for fertilizers and so on. But some of this stuff can leak and leach out. If it does, it's very minor. It can make its way maybe to the Colorado River, but it's not that toxic. And there's not, where it's flowing through, it's not a very populated area. It's Canyonlands National Monument. But as you go by this area, you go by this big pile. This is an old tailings pile of uranium-related rock that was in association with the uranium deposits in that. So it's kind of like a tailings pile, and it's right next to the Colorado River. And of course, aquifer systems for them are also coming out of here. So they had a major concern. This is a kind of Superfund area that they wanted to work on, and they've been pretty successful about covering it up and monitoring that. It's all fenced in now, but this old uranium tailings dump is something to see. So yeah, we've had our nuclear tests out west a long time ago. The ground got pockmarked. There's a lot of contaminated stuff we had when we made the bombs to whatever, and we've got to get rid of it. So we all have this whole stuff of whether it's the testing of our bombs to nuclear uses for nuclear power plants to low-level radiation types of things used in hospitals. There's even radioactive substances used in geophysical logging and stuff. So there's radioactive stuff around us, and we really have you have to watch it. So there's lots of interesting parts on this map of the United States. It says spent nuclear fuel elements. I mean, that's all the stuff related to it. And high level, the worst stuff, radioactive waste in the United States. And these are from different, all the different kind of symbols and colors represent where it's coming from. Okay, commercial spent nuclear fuel storage, shut down reactors with spent nuclear fuel on site. Shut down reactor without spent nuclear fuel on site. And the list goes on. The point is that some of it's still hot, and some of it's not quite as hot radioactively. And they're really being worked on. So we want to put this stuff underground and dispose of it. One thought at one time was to put it into the big salt domes down the Gulf Coast states of Mississippi, Louisiana, and Texas. And there may be some in there, but the salt is kind of a mobile thing, and even though it's impermeable to water, they're not going to look at that. I'll show you the main site we're talking about in just a bit. One of the test plants they set up, kind of an experimental plant, is this one, WIPP. W-I-P-P. WIPP is an acronym for Waste Isolation Pilot Plant down in southeastern New Mexico. And you can see the blow up of the map. It's out here, outside of Carlsbad. In fact, Carlsbad just made the news recently. Do you know why? In the last, 2-3 days? Anybody remember that? It has to do with flooding. They had some major flooding down there. I'm interested to see what kind of infiltration they had around here. But underground is this huge facility to get rid of nuclear waste. This is an air view of it. They've got this detailed map. They have a website you can go to and check things out. And here's what it kind of looks like underground. And these are the waste. They classify this stuff as transuranic waste. You might want to write that down. Transuranic waste. It's the high radioactive stuff. Okay? And so here they are kind of working on the walls, getting ready to set and insert a canister into saltier zones in these areas. These are not salt domes and plugs like we see in the Gulf Coast area. These are more layered salts, the Permian Basin. And they'll then encase these things, and there it is. So we want to hope that it stays. We can see steel. We've got rock bolts in the ceiling. We've got this stuff, with the walls encased, and it's going to sit there, and we hope that nothing happens to it for a long, long time. So the groundwater doesn't get in there. So we're choosing places in the desert zones as far as we can, away from people. Here's kind of a thing about WIPP. You don't have to write the whole thing down. You can kind of look at it. The Waste Isolation Plant, or WIPP, is the world's first. That's the key thing. Maybe you could write that down. It's the first underground repository that was licensed. Licensed. Key word there. First underground repository licensed to safely and permanently dispose of transuranic radioactive waste. And we have a lot of stuff to store. A lot of it's piled up we have to work with. Another view of it showing you some of what the canisters look like internally, the different kinds of waste that they encase in those things and pile it up. A lot to be buried. There's another site out in Nevada that we're all working on and looking at. Some of our old test sites out here of nuclear bombs and so on. Called Yucca Mountain area. And we've been researching. There's chemists, geologists, physicists, managers, state agencies, federal agencies, and the list goes on and on about studying this spot. Because this is one of the biggies that we have in a plan to take a lot of our nuclear waste in this country from that, remember that map of the United States with all those different spots on it, and put it here. Still not activated yet. The studies are going on for a lot of reasons. This is a website you can go to. It's not federal. There are a group of people who are interested in keeping an eye on them to say, are you doing the right thing, or should we try to stop you? Again, you've got both sides of the coin to think about. And you got the extreme environmental side, and you got the other side that says we've got stuff we've got to get rid of, and we're going to do it. And everywhere in between, a whole rainbow of levels of people looking at this one, because this is such a big deal. Every now and then you'll hear something on the news or watch something about your state. I know Nebraska said we're not going to get involved in this nuclear waste thing and stuff. So it's like not everybody wants this stuff. Nobody wants this stuff in their backyard, you see. So I don't have the website on here, but if you write this word down, you can probably find it really easy. And I don't even want to take an adventure of pronouncing that. It's probably some indigenous tribe here. Could be Navajo, but I'm not sure. Oh, what does it say? Western Shoshone. I'm sorry. Western Shoshone name, meaning peace and harmony with all creation. So that's kind of their name. They're like a Sierra Club group, kind of keeping an eye on that spot out there. Here's one of the figures from your text. Why is it a concern? Well, here we got this spot out there in Nevada. It's out in the middle of the desert, mostly federal land, so it's cheap. Not a lot of big cities nearby, so it's not a bad spot to pick. But geologically, it's a very highly faulted zone in the Basin and Range province of the United States. Lots of ancient faults, a lot of younger faults geologically, and it's got earthquake activity. So what if at one point in time you get a big fault, activates, rips it open, and then, see, that's the concern. So they're really checking out a lot of things. You can check out sites, again, online about earthquakes, how often they occur, and how big are they. It's ammunition to the groups to say, see, we told you so, you shouldn't put it here. On the other hand, where are we going to put this stuff? There was another permit request put out, about 2 to 3 weeks ago for another nuclear power plant to be built in the United States. Heard this on CNN. But they didn't say where. They didn't say where they wanted to build it. They just want to get the permit to do it. So it'll be interesting to watch that in the next 6 months to a year as to that process of what state is going to win that situation to have a new nuclear power plant built. Another quick map of really zeroing in right on Yucca Mountain. There's that repository. It's kind of open on that spot, so I guess it's not too bad, but still, what could happen? Here's some of the more recent quakes in the zone, some of the old faults. Well, we do have another spot, a repository in our country, up in the state of Washington. So you need to remember the name of this one. It's called the Hanford plant. Hanford's up in the state of Washington, our Pacific Northwest, near Richland. And here's what it looks like as they're processing. They've got these big encased in concrete buildings, lots of monitoring things and venting things and so on. And once they get all that stuff encased in canisters within that, then they'll bury this whole thing. Right now they're filling it up, and eventually they'll just cover this up and bury it. But very high level radioactive material goes in and out of these plants. In the bottom right-hand corner, looking down through the water coolant of spent fuel rods. Here they have, the canisters are closed up, and they're going to take these canisters and then put them in another canister, and another canister, and a bigger canister, and bury it in the ground. And that's the way we do it. They've even got some really wild, new, interesting toys to help us do it so that the workers don't get contaminated as much. It's almost futuristic. They've got this giant, great big robotic arm they've nicknamed Conan to grasp. Here's when Conan is being delivered to the Hanford plant, and then in duty, hauling one of those great big huge spent rod canisters out of there and putting it on a dolly to move out, and of course put it in another canister with others, and then eventually put inside those big concrete things and dispose of it. So we've just looked at the landfill, the idea of putting the stuff in the ground, but it's got to go from point A to point B. It's got to be transported. Now you've seen garbage trucks go to the dump, okay? Well, sometimes, and I've seen a few, I haven't seen this one, but I've seen some instances where I've seen some trucks with some interesting signs. This past summer I went down to the southeast part of the country and I saw this huge truck. It had radioactivity on it, but it was probably low-level radioactivity, but this stuff is being transported by train and by truck mainly. And so where will it go? And again, the concern is, what if there's an accident? What if there's a terrorist situation of this stuff going? Now take a look at how far they've gone to encase this critter. And there's probably just something very small inside that whole thing. Here's Kansas's radioactive waste routes maps, where they could go, where they may go. You can see I-70 running through the center of the state. I dug up this thing, and I'm hoping this will work. You can click on this website. Why don't you write that down? www.lvisible.com/yucca. This is if it works, I hope it does here, is an animated GIF of a map showing when we take these radioactive things from those spots in the United States and we're going to truck it to Yucca Mountain. So let me click on this and see if it'll work. Okay. Let it kick in here and see how fast the web is today here. We'll give it a few more seconds here and see if it'll actually do something. Something's working. Almost there, I think. And kick in. I hope it does this, because it's kind of unique just to see this map, with little arrows and kind of like worm-like things heading towards us. Hitting the wall, isn't it? Oh, here we go. I know that's nothing unique, but it is the pathway, the planned way to bring that to the United States. And of course, here we are in Kansas. This is I-70. And you see where it's coming from. All of this here is going down right through I-70. So if you live in one of these states, you could see, you may be from some other part of the country or whatever. If you're at the distance site right now listening to this, see where you're at. That's the plan. Whether this comes about or not, we don't know. We still haven't opened it up, and it may or may not happen. So anyway, let's go on back down to this and move on. So I thought this figure in your text was kind of interesting. Again, we've looked at the landfills, from the bad to the good, how we might bury and try to encase things the best we can, where some of the high-level radioactive waste will go. But we've got these sites that we call Superfund sites. A lot of our tax dollars go into this big pot of money called the Superfund. And then state, federal, private, environmental-related groups get into this to try to clean these places up. And there's different polluted spots around the country, Superfund areas. And so these are the dump sites proposed for EPA Superfund cleanup. And here in Kansas, we have 8. Let's see which is the biggest one here. Michigan's got 69, 80. Whoa, 80 in Pennsylvania. 100 in New Jersey. Okay, New Jersey's a lot smaller. And take a look at Nevada. 0. Now, if Yucca Mountain comes into plan, let's hope that it stays a long time. Nice and safe, so this still stays a 0 out there as far as radioactive waste is concerned. So I thought I'd kind of get close to an ending here and give you this acronym. Some of you probably know this from other classes or other sources. NIMBY, N-I-M-B-Y. Write that down, NIMBY. I stole this garbage man thing off the website somewhere. I'm not using it to offend anyone. It's just that it's kind of, sometimes we have a lot of garbage. I don't know if you remember some years back when there was this barge coming off the coast of New York City, and this barge was trying to come into a port so it could take its garbage, and everybody kept sending it away. It finally went off somewhere, and then they were worried about it, sinking in the ocean, but it was somebody else's garbage. Not in my backyard. NIMBY, not in my backyard. That's what that stands for. So who knows where our garbage will be, but along with water, this is certainly related to water quality as an issue to think about, but there's lots and lots of jobs, again, associated with garbage. You may not think about it. So even though I say rest easy, don't forget to get involved, okay? I think that's it for today. So we'll see you next time.